Hi guys and welcome to 2dv013. Today we have our first guest lecture with Jonas, and we will dive into Google Cloud and infrastructure as code and see some real examples from industry. It's really nice to have Jonas here. Thank you, Diana, for connecting us. Jonas has been active in different networks at LNU and have been presenting, but never been in the classroom, even though virtual. So welcome to us today. We will go for the full 2 academic quarters, and we'll try to record everything. And we will have a short pause, right, in somewhere in the middle, when we will have a be right back screen and everyone can grab coffee. So I'll give the stage to you, and we'll handle all the pause and starts in the background. So please.
Sounds great. All right, let's see. Welcome to this intro into Google Cloud and Infrastructure as Code. And when I was asked to do this presentation, I thought I can do this standing on my head and just present how Google Cloud works. But I also thought that given that we actually have access to a lot of courses online, and how to solve something can actually be solved quite easily with your Geminis and Copilots, I would actually focus a bit more about what it actually means to be cloud native. And I'll put it in a frame of Google Cloud and Infrastructure as Code. So I hope you'll be interested about this. Let's see. All right, so the agenda will be, I'll present myself. I will present you with some learning links for some classical cloud learnings. And I will also teach you about billing budgets, because when you start using Google Cloud, you should really set one. Serverless costs are real, and it scales really well. So I will then do an introduction to Google and Google Cloud, or to Cloud and Google Cloud. And then we'll start to look at how to build stuff from something really simple, and then going all up to the industry example within 20 minutes. And then we'll go for Infrastructure as Code. I'll go for a quick kind of recap of Terraform and Infrastructure as Code and the objectives of it, and then quickly start to talk about Terraform modules and how to kind of modularize your settings. Usually when I do this kind of presentation, we have kind of 5 minutes breaks between each block in case to kind of get some feedback and see, is the pacing all right, or do you have any questions? And you can grab a cup of coffee in those 5 minutes. I think we'll pause the stream when this happens. All right, I'm usually called a cloud architect. I work at a company called Imeto. We've been around for about a year. And the focus is cloud data and AI, which is nice. And I've been around about 20 years professionally. So I've gone from a software developer to a kind of a DevOps role. It wasn't called that back then. Now I'm mainly called a cloud architect, and my focus as of about 5 years is mainly data and AI workloads, because that's where everyone is going, basically. Education is important. I have studied at BTH in Blekinge and in Jönköping University. No, not Jönköping. Yeah, Jönköping University, exactly. Both in electrical engineering. So I kind of have a computer science background in that sense. And Imeto is about helping European companies become self-sufficient. And that would kind of be the theme of this presentation, how to kind of become self-sufficient in what you do. Because just doing a delivery and then leaving you with something that you can't use is really not that important. It's important that you have a capability that you can grow from and iterate and learn about. So that's about it. All right. So if you thought this was going to be like a very classical, here's Google Cloud, this is a network, this is kind of a data center sort of thing, this is already available. Google offers something called Cloud Skills Boost. I think it might be free for students, but I'm not a student, so I don't know how to do that. But if you sign up, you actually can get something called I think it's called, I can't remember the name, something like Builders something, or you'd get at least 35 credits per month when you do the labs, which are actually real sandboxed GCP environments. You actually have to pay labs, but all the video learnings and everything else is free. So it's just about signing up. There's a cloud developer learning path, which is great if you want to do sort of the end-to-end, where you get an introduction, you get how to run your cloud services and how to monitor them. So I can really recommend that. It takes about some 40 to 60 hours of actually looking into. But that will get you started in this course really well in Google Cloud. So Terraform is not included in that path, but there are other lab series about that, how to set it up. So follow those links. I will share the slides afterwards. All right, that was about 5 minutes. The first thing you need to do set your billing budgets. It's really cheap in GCP, but it does really scale extremely fast if needed. So you need to set your scaling limits. And be careful about sharing service keys or running big queries in BigQuery, that sort of thing, because it does scale and it does cost. This is usually where people mess up. So when you start out, it really doesn't cost much at all. It should last you months, even if you run a small GKE cluster. But do set a billing budget. There are instructions online how to do this. And the idea is to set it on $300 so you know when you run out of money, because that you don't want to just leave it ticking and then you get a surprise at the end of the month. I thought I skipped a slide, but there are words I will use that might not be entirely correct. When you kind of review this presentation and there's something you don't understand, go back to this. This is actually hidden in my presentation, but this can be useful for you. All right, that's the intro done. So the introduction to cloud and GCP. So when we talk about cloud native, what does this actually mean? And my take on this is it's not just about technology. It's not just how you run your services. It's not just how you deliver your workloads to your clients. So there are 4 aspects of kind of this. This is kind of classical change management part, but you have people in organization. It's how do you actually organize? What did people need to know and kind of be responsible for? And how do you collaborate? This you have to kind of think about, because if you create a cloud operation or a cloud solution, I will go into a bit what that means, or a cloud platform, where you do not ensure that you follow the structure that that the organization has, that you ensure that the responsibilities, that budgets are followed up, or you know who owns a project and it's being maintained, it will all just rot. And you will call me up in 5 years and say, I've lost control. So this is kind of the reason why you need to have this in mind when you build it. But you can't ignore the people. So you need to kind of create processes and have adoption of the cloud. As you can see, the kid is a bit surly here. And that's usually the case. You have one team part of the organization that's really excited about cloud, usually the technology people. And then you have the people who are less happy about cloud, also the technology people, depending on if that's something they built, if that's something that needs to change. It might not be easy. And it means, the first process you will feel as a student is getting onboarded. That's a common process. You need to get access to IT systems or similar. And you've probably felt it at LNU. And if you when you join your internships at the companies, you will also feel the onboarding process. That's the first one you feel. My recommendation is that when you hit one of these processes, you should contribute to it, because that's how we get adoption and a living process. So think about that. And that means that when we create something that is a cloud platform, you need to think about, what do we actually commonly do? Does it work really well? How do we document what we do? Because if we can't, inform people of how you should be working with cloud, people will do it in their own way, and you end up with something that's unmaintainable again. So if we look at the technology part, it's how the question isn't really like, sure, how to support your business. Yes, we need to deliver this web page out to our clients so they can click somewhere and buy something. That's kind of the business idea, right? But a lot of the things we do in cloud is actually how to support the organization. How do you do development? How do you make sure that people understand how to consume, or kind of how do you get to a database, for instance? How do you find it in your organization? How does CI/CD work? Can we contribute code? And you're also the non-development parts of it. How to support organization within IT. That's also part of cloud, like Workspace or what is it called now? Copilot 365. Well, your document stuff. That actually ties together really much. So it's a tight coupling between those two. And your job in the technology part when building a cloud platform is actually getting data and compute where it needs to be. That is truly it. And the biggest challenge we have in being on-prem is that we have servers, but getting the workload to those servers happens within the order of days, or better, hours. And we use technologies like Kubernetes, even on-premise, to make sure that your workload can be spun up in the right data center where it needs to be, where you have the capacity. And one big part is also the data aspect of it. How do we get the data where it needs to be? And in the end, we need to get AI into everything. I'm kidding here a bit, but almost no, because it's truly happening at clients. Everyone needs to have, when we have the Gen AI boom that's happening right now, a lot of the work is about how do we make sure that these Gen AIs can reach the activation and the data sources that they need to kind of get enough context to understand the business and be able to communicate and activate the things you need to do. So jokes aside, it is happening truly. The fourth part is governance. That's something that is much harder than everything else, to be honest, because building something is easy. Governance is about how do we make sure that it actually looks nice. When everything looks, if you look at a favela, it means it really does work. I mean, people have somewhere to live, people can, go to work, people can find food. Everything sort of works, but it's really hard to change something because you can only change one thing at a time. You can't say all of these houses look the same, so we need to fix the plumbing at exactly the same rate. We need to do it every 20 years or 10 years or so. It's also about reproducibility. If you have a custom-built hut, it's really difficult to say, I know exactly how this was built because it was built over 10 years and we put on some tape every time. If we have something that's modular and a mold to do things in, it looks the same, it means we can treat them the same. It becomes a large-scale operation. Something that really drives complexity and complicates your solutions is actually security and compliance. Because that's about risk. How do we make sure that we are within, security boundaries and that we are compliant with regulations and laws and contracts that we are bound to? And some companies have really good focus on this, which means that you can probably don't do anything. I've been at assignments where I've been allowed to see any production data or any production systems, and I was supposed to redesign the whole thing, which becomes funny if the development environment doesn't really look like the production environment, which is usually, unfortunately, the case. And clear ownership of the entire life cycle. You need to create stuff, you need to migrate and configure stuff, and then when it's time to get rid of it, you need to destroy it. And the hardest part is always to destroy stuff. You always want to keep it around. So that's why we kind of need to make sure that you know who owns this. All right. So the first question is who's responsible for what? And this is where your entry to Google Cloud starts. So in Google Cloud, we have our organizational hierarchy or resource hierarchy, which consists of an organization, which is basically a domain. If you have your own domain name, you can register your own organization. It's actually free. You don't. It's part of Workspace, so you can do that if you want to. If you just log in with a Google account or a Gmail account, you won't see the folder structure at all. You will just see projects, and that's about it. Folders, anyways, we use those a lot to kind of create a structure for ownership. And we try to match the responsibilities and access that you're granted in the organization. A common pattern I use is actually to follow the account structure. to make sure that costs are distributed correctly, because if something is costing a lot of money, somebody cares. If something is costing a lot of money and nobody is responsible for that cost, it's someone else's problem. So please make sure that when you build something, make sure that whoever is running that system gets the alerts, gets the cost, and gets the full responsibility of whatever service you deploy. That means that there is an incentive for those people to change and improve that system if something fails. In cloud, stuff doesn't usually go slower. It costs more if you build it poorly. So that's why it's important to actually follow up on cost and drive it, because it's a big way of making change. I really like that teams have responsibility of their own environments. So we usually have a team level folder, and then you can set up multiple environments in those folders. When we do this, we actually do it with infrastructure as code. So we actually create a department module, a team module, and then we use Terraform workspaces to deploy multiple environments. It means that when we onboard the next team, it's onboarded the same. If we need to change something because teams are different, either we have a problem in the organization or we align all the teams. And if it turns out we have a problem in the organization, we start to figure out, where do we fix it? Do we fix it up in the left-hand side of that presentation we had yesterday, where we talked, or last slide we had, where we talked about organization and responsibilities, or do we fix it in the technology side, where we do, oh, this team is special, so we need to have a feature flag on our Terraform module that this team is entirely different. Anyway, so what you mostly will see are projects, which is a very confusing term for many organizations, because a project is usually something else. It means a time-bounded initiative that ends. Projects are not usually time-bounded, and they are usually never removed unless an entire service or something is removed. If you want to have a cost for something, it needs to belong to a project. A billing account needs to be connected to the project, otherwise you're not allowed to create any resources. So there can't be any costs anywhere else unless there is, well, sort of, but standard resources unless you do purchase a license of something, which you won't do normally as kind of an end user. But resources are connected to projects, basically. And then you have a billing account. It's not actually connected to the organization at all, which is also strange for people, but a billing account is entirely separate. So when you when you're looking at your Google account, you're asked to create a billing account. It's only visible on the billing side, and then you connect it to a project, and then you kind of forget that it was there, because you usually don't change much unless you want to create more projects when you need to associate the billing account. But go in there and figure it out and see what it looks like and see what kind of costs you're getting there. The interesting thing here now is that if you set an IAM permission, or deny policy is also possible, but let's start with the IAM the grants, basically. If you are a member of a team, you should probably have access to that team's environments. So you usually create a team group and you grant the access on the team folder. It means that IAM is very easily and transparent and understandable. I have a member of a team, I get access to certain things. It's the first thing that people mess up. If you start granting access on personal level and it's not part of the structure of the company and it doesn't match the team alignment, you will spend most of the time assigning permissions, and that's not something that is very productive for the company, to be honest. And policies is also something that limits what you can do within Google Cloud. So it limits, say, that you can limit that you can only grant access to people within a certain domain. So if you say, I can only grant access to LNU members, that's something that's limited. And that also travels down from the top. You can set it on organizational level. It applies to everything down to resource level. Same with IAM policies. Financial reporting costs are actually connected upwards. So you can actually look at a team and say, what is the team cost from a resource perspective or a cloud perspective, or you can look at a department and say what that costs. Again, cost is a great driver for making change. Same thing with logs. You can put log syncs on different levels on folders and collect every single piece of logging that goes from application logs and, more importantly, audit logs. Because if you know what your audit logs monitor everything that happens in your cloud. So there's never any question about the state of your cloud, and that brings trust from the people that from you, basically, or that you know what has happened in the cloud. You can always go back and say, oh, we did that change back when. And IAM logs actually don't cost anything. It's something that Google wants you to keep around. So that's a great thing. We usually put an audit log project at the top that collects everything and sends it off to an intrusion detection system or a CM system that actually monitors everything. All right. Of course, we're a little bit behind already. Identity access management. When you will spend a lot of time with figuring out who am I, or who is doing what, and what permission does it have. And the who is a user, that's you, or it's a group where you belong. You can also, there's a specific group that's on a domain, so you can grant access to everyone at LNU to do something. Be a bit careful with this, because it means that everyone that has an email that ends with this domain has access to do whatever you tell it to. But it can also be great if you want someone to be able to access your page or something. Right? Everything in Google needs an identity. So every service is running as a service account. It's also an email, so you can actually grant that service account access even in Google Drive if it needs to read a Google Drive document, for instance. That's quite possible and quite useful, actually. And IAM can be time-consuming to do right. You get a default compute engine that is kind of, it has the permissions to do everything, and by default that's being used. This is to make sure that people don't get unhappy with GCP and say, it's a piece of crap, I can't use it, nothing works. But it also means that if you use that service account, something goes wrong, and someone is able to act as that service account, they can actually spin up, thousands of machines and start mining Bitcoins. I've seen it done. So be very careful about having broad permissions in service accounts, especially when you create keys. Nowadays, if you create a service key, which is kind of a file that allows you to act as that service account, if you put that on GitHub or anywhere else publicly, there are actually safeguards in place that will find it and remove it and revoke it automatically in GCP. So if GCP detects you pushed something to GitHub, they will remove that key from GCP. They will override, they will step in and remove it nowadays. It wasn't the case a few years ago, so that could be really expensive. So the principle of least privilege is that you should grant the service account just enough permissions to do what it needs to do, as the web service it's running, for instance. We use a lot of impersonation to say that we usually don't do things as ourselves. We are acting as a service account. This is very common within Terraform, for instance. Because sometimes when you create something, you will get permissions on the acting party that created something. It needs to be Terraform, not you. Otherwise, I end up as owner of a project, and then my colleague comes in and tries to do the same, and it doesn't work because he does not have the same permissions. There's something called custom roles. In Google, a permission is actually an API call. And permissions get grouped into roles, which is a collection of API calls that make sense. So to be a Cloud Run user, you're allowed to call certain API endpoints within Google Cloud. If it complains and says you're missing this permission, it's really tempting to say, okay, I'll create a custom role, exactly this permission, and I start building on a role which have the permissions I need, being able to call the API calls I need. Don't do this. It's really hard to maintain in the long run. Look up the IAM pages and say, okay, I'm lacking this permission. Which role has this permission? And then you add that role. It will be something useful, like this is a Cloud Run invoker, or more like a Cloud Run developer. A Cloud Run developer allows you to deploy new versions of Cloud Run. A Cloud Run invoker is allowed to call the function. Don't try to figure that out. Google has a really good set of abstractions for it. So check the IAM pages for roles that matches the permissions you need. Okay, I think we're behind schedule. So right, I think we're actually pretty good. If you want, we could take a 5-minute break here. But since I don't have that much feedback in this medium, I'm not sure if we just want to continue or if you want to take a break. Let's see. Should we take a 5-minute break?
I think we can go a bit longer.
All right, let's go on. Nobody's lagging then. All right. So the building stuff with GCP would be kind of the next section here. And I found you should quote stuff off the internet, I've heard. So I found one, or it's actually a colleague of mine who had a really good point here. So when you build stuff, you will see kind of, I will present how a professional system evolves. So this quote is like, a complex system that works is invariably found to have evolved from a simple system that worked. A complex system designed from scratch never works and cannot be patched up to make it work. You have to start over with a working simple system. If someone says, we want to do a use case-driven approach, this is it. It means we start with something that adds value, but works end to end. And then we build on the next use case to make sure that we can handle, or we actually start with 2 use cases to make sure that we can handle a set of problems, basically. We should never start building a really complex platform that does nothing, because then it's optimized to do nothing. So this is it. So you want to host a web service on Google Cloud. There are many more things you can do with Google Cloud, but I thought this might actually be something that is right up your alley. So you have a few options. You can have Google Cloud is actually based on APIs. We rarely drag in networking on TCP level unless you start working with VMs. So it means if you want something that's HTTP, it's actually like first citizen in GCP. We mainly work on an HTTP API calls basis and goes to Google Cloud APIs. So it's really, really easy to work with this. It's not like AWS where you need to start with networking. And if you want to route stuff globally in Google Cloud, it's actually by default global networks. So it's actually kind of nice. Anyways, so if you want to start hosting, say, static content, the easiest way to do this is put it in a cloud storage bucket. A cloud storage bucket is a blob store. It's S3 compatible, the AWS S3, so it can handle any kind of file. It's great for, you can just use it for an HTML-based or static file-based web page, but you can also have it for just pictures, for instance, video files. I've built a streaming video service based on cloud storage where you can actually access, you can actually look into, it can stream parts of the file, so it can start streaming in the middle of the file as well. This is supported. And I've done some really hacky stuff where I put like a static API as a plain JSON file, or a CSV for a data dump for, say, if you want to showcase some data in a web page. So cloud storage is something that you will use quite often, and it's quite nice to have it internet facing. There is something called unified access. It means that you can only have one rule. Otherwise, you can have rules based on paths in the storage bucket. Don't have rules based on path. It's too complicated. You will lose track and you will grant access to someone. Basically, have one bucket, have one access level. Everything in this bucket is either public or private or access to someone specific. And if you have to have more sets of accesses, just create another storage bucket under your project. It's quite easy. Storage buckets, because they can be made public, have globally unique names. It's the same thing with projects. When you create them, they have a project ID, they're globally unique. So you cannot override someone else's. But it also means that if you want to expose it, it is globally unique. So it can be exposed as a globally unique API endpoint. Nice. So if you want to do something more complicated that's running server side, you can use either Cloud Functions or Cloud Run. They used to be different. They are not. They're the same. They are actually just the same service now. Functions are actually now in Google Cloud called Cloud Run Functions. And it's basically a container service. It scales down to 0. It scales up within seconds. It's really fast. You can actually have it If you have a rarely used API or a rarely used web page, you can scale it down to 0. I have hosted commercial web pages scaling down to 0 because it's no point in having something running if it's not always used. It is kind of nice with these because you can actually attach cloud storage volumes as paths within your application, your container. So if you say, I want to put my pictures on /pictures, you can actually just attach that a storage bucket instead of building it into your image, because you don't want stuff like that in a container image. You can also connect databases automatically to make sure that your service account, so the service account that the functional Cloud Run service is running as can actually get access to a database. That way we don't have to pass usernames and passwords that can be leaked. It's always a short-lived JOT token then. But basically, think of this as a way of running containers, one way or the other. Functions used to be limited to certain programming languages. Sure, you can do that, but you can also just, run any container nowadays, as long as it starts fast enough. It will replace the container as needed. It will scale up and down. So you can't have any sort of state handling within the container. It needs to be, you have to kind of consider it to be fresh every call coming into your application. So if you have some state that you need to keep somewhere, put it somewhere else in a database or in a Redis or Memcache or similar cache that you can have. But Cloud Run and functions, they are always stateless. They're something that you can't really argue with. So then you have Kubernetes and Compute Engine. Compute Engine, they're VMs. Both of these, if you set them up in a recommended way, contains either a cluster or a group of VMs to usually host containers. Yes, you can actually do to run VMs that actually you install stuff on. And in most cases, when you get examples of VMs, you're asked to kind of, can you install this web service on it? That's not really interesting. We actually do want to run a container on it, because when we build a container, we have all the dependencies in place. When we remove the containers, everything is gone. When we upgrade a library and patch a security flaw in the container, it fixes that unique. It becomes atomic. You can't do it halfway. So I usually nowadays, even if I run a virtual machine, because somebody says, "Oh, I do want a virtual machine, but I don't want Kubernetes," I end up adding an instruction to run a container on it. So in GCP, you can say, start this VM, but also start this container and expose these ports. We will get more into Kubernetes engine later on, I think, and so I won't go into more than that. But basically means that we have 3 options when hosting services in Google Cloud. As a containerized service that is managed by Google, or sort of a containerized service that is more managed by you. So simple. So these are your options. And you can actually go to a Cloud Function, click New. It will say, here's where you edit your source, and then you can actually deploy it, and you get an URL endpoint you can call it, and that's basically it. But is that how we do it professionally? Well, you kind of should have a load balancer if you want to do this in a productionized manner. You want it to have your company domain. So mycompany.com should be somewhere. We get to that in a bit, but the first thing you want to do is have a load balancer in place to kind of, if someone starts DDoSing you, if the request is coming somewhere globally, it will actually be routed into Google's network. They can handle an enormous load, and it can protect your service from DDoS attacks, especially if you implement stuff like web application firewalls, what we get to in a bit. If you set a cloud load balancer, it will start to use something called health checks. So we'll actually start checking if your service is healthy. And that is done through something called a backend. You have a backend bucket for storage, and you have backend services for functions and Cloud Run. And as well as Kubernetes and Compute Engine. They are implemented slightly differently, because for Kubernetes Engine and Compute Engine, it will be a network thing, more or less. It will be a network endpoint group. And that actually gets routed through real networks. In the functions and Cloud Run case, it will be a serverless endpoint, which means that that's something Google will manage for you. But you actually end up with the same kind of primary entity that's called a backend. And firewalls is important. If you have a virtual machine and you expose every port to the internet, you will get hacked. It's just a matter of time. Firewall can prevent that slightly by limiting it to those ports you want to expose. So you should set it. But it also means that if you set up a load balancer externally, it will start to do, you need to specify how do I check the health of this compute? Because if any of my services are not healthy, I should not route traffic to it. It should stop routing traffic to it. And that's something you need to set up in firewalls. This is where Kubernetes and virtual machines are slightly different. Kubernetes has a cloud operator that does this for you. It will configure the cloud to match. But if you, after setting up Kubernetes, or GKE as it's called in Google Cloud, the result will actually be the best practice how to set up a virtual machine in Google Cloud using load balancers, firewalls, backend services, and everything. So if you want to learn how to set up virtual machines in Google Cloud, start with Kubernetes, because that will tell you how you should be doing it. So if you're not using Kubernetes and using virtual machines, you will end up having to configure firewalls, setting up backend service, setting up groups of compute engine nodes and make them auto-scale. And that's exactly what Kubernetes does for you using a different abstraction. But we'll get to that later. But there's a bit of complexity already, right? You're noticing this. We have started to, instead of just having storage function, Cloud Run on Kubernetes engine and compute engine, we end up with all of these new entities that we kind of have to manage. You can manage these through Terraform, of course. Then. The nice thing then when you get to this backend service and backend bucket is that you can attach additional services to them or functions on them. One is CDN, that's content delivery networks. So if you're serving something in a storage bucket, you could fetch it from the storage bucket where you stored it every time. A storage bucket is regional or multi-regional, so it spreads its data either in one data center or in a region within say the EU or the US or your different multi-regionals anyways. So what CDN does is it actually moves whatever data is being requested closer to the points of presence Google has. So before Google had a data center in Sweden, they already had a point of presence in Stockholm, which meant that if you would serve a file in a data center in the EU and you would enable CDN and people would start fetching files, that content would be moved closer to Stockholm if most of your user base was there. So that's why. The reason for this is also that it becomes faster for your clients because it's closer, but it also reduces your egress costs, which means the data that flows onto the internet. Cloud providers want data, so anything going into the cloud is free, everything going out of the cloud is not. So that's something that you will notice once you start working with large volumes of data. And this is why data is fun. You also can set something called a web application firewall. It's called Cloud Armor, I think, in Google. And this enables you to have rules that prevent common attacks and block IP addresses and that sort of thing. That's also one way of it is AI enabled now, so it can automatically apply rules, but that's not free anymore. So one thing that I can recommend you to look into if you want to show web services online, but not to everyone, is actually to add something called identity-aware proxy. Then you just specify a Google address, Google group, or a domain that can access your web page. And then if you go there, it will actually ask you to log into Google. And once you're in, transparently, you will get access to that service. And you can actually have, if you have the same identity-aware proxy for multiple services, you can actually have it for both the front end and the back end, and it will transparently add access tokens to the backend responses as well. So it becomes kind of transparent. So you don't have to kind of fix something on the backend side. So this is a smart way to kind of run dev environments you don't want to showcase to the world. But as you can see, we went from kind of easily just putting up a storage bucket and running functions in Cloud Run, and now you're actually have a load balancer in there to protect you from harm, and adding these features such as identity-aware proxy, CDN, and web application firewalls. So, but nobody will trust your domain or your service unless you have a managed certificate or DNS server. So then you need to put DNS on top. You need to specify which domains you are hosting. And Cloud DNS is basically a DNS service where you can set which records to display on the internet. You use A records to specify which IPs. So in this case, you would say the A record for my domain would be the IP address of the cloud load balancer. So anyone going to my domain, mycoolapp.com, it will get a response to say, go to this load balancer. In the load balancer, you say, for this host, route to this function, this service, and for that path, route to that service. So it enables you to kind of have one entry point for all of your different services. But you also need a certificate. But since owning a domain and being able to set a TXT record on a domain is kind of the authority of saying, this is my domain, you have something called managed certificates. I'm thinking you might have heard of Let's Encrypt, which is the same. It uses basically challenges. It will expose an endpoint saying that if you can call this endpoint and read this information, it's called HTTP 01 challenge. Or if you can read if you can set a text record containing this challenge on the domain, I will trust that you own this domain. And managed certificates is a service in GCP where you can set and say, this is a domain I will manage. Whew. Now we've come kind of full way. This is actually how we build managed web services in GCP. We don't just plunk out a function and on the internet or Cloud Run or Kubernetes engine, but this is kind of the end-to-end. And in Kubernetes, this is actually part of the Kubernetes plane. It's kind of cool, but it's also hard to manage in its own way. So you can kind of choose your aches and pains here. But this is the full industry example. And by leveraging Terraform, as we will talk about in the next section, we can actually create modules for each. So you can create kind of a storage bucket with a backend specifying everything you need. Same thing with a function, Cloud Run and Kubernetes engine and Compute engine. Specify which hosts you want to serve each thing on. And you end up with a very small configuration to drive a lot of different web services on. And this can actually mean that you have created a very useful cloud platform for web hosting that doesn't lock your users into specifics. If you want to have static content, say you need a bucket. And the point is getting it online safely with CDN enabled so it doesn't cost a fortune to send on the internet, with a domain that is validated and ready so your users can consume the data in the storage bucket. So this is how you build it. So if you think it's a lot, it is a lot. But as I said, you start simple with just creating your plain function, and then you add on top of that. All right, infrastructure as code. I think we have 30 minutes left, and I think that will probably cover it. So I think we'll skip the break again, if you don't mind. These things always take a bit longer than you think. So let's move on directly to infrastructure as code. So the focus here will be sort of how does it work and how does it help? Because infrastructure as code just enables you to create cloud resources as code. But unless you actually go about it in a structured way, it will basically become your favela again of code that you need to maintain. So let's jump into this. All right, infrastructure as code. The difference here is that if you script something, it will be empirical. You say, do this, create my virtual machine or create my cloud service, destroy my cloud service, change the image of the cloud service to this version because I just made some new features on my web service. This is hard to maintain. But what infrastructure as code does is that you use a descriptive or declarative notion to say, this is what I want it to be. And it makes sure that whatever you wanted, this is what will end up. So we use a declarative way of defining resources. So in Terraform specifically, we have something called a resource. It's a named type of resource. So a VM is a resource, a cloud run service is a resource. If it's declared as a resource, it's something that if you create, modify, and destroy as needed. You can also, most resources also have a data equivalent. It means that it's something that exists. You can read data about it, but it's not something that it will be that you manage the life cycle of. You won't create it. You won't change it. You won't destroy it. You will only read data from it. So how do we actually end up with this declarative way to make sure that it actually ends up that way? Well, we need to remember how it was, how something was done, right? So we have what we call a backend, a state file, and it literally is a file. If you can say where it's supposed to be stored. You can start out with storing it in your repo. It's great if you're a single developer, but pretty soon, if you are multiple people working on this, you want to put the state somewhere where it can be reached by all your developers. So that's usually a cloud storage bucket. So that means when you start developing, if you do a change, someone else want to do a change, they will read and say, oh, this exists. I need to make, these changes need to be made. So when you have multiple developers, you actually do end up ping-ponging each other's resources and killing off each other's stuff that you built. It's not that bad because you still have the declared code where you want to be when you're done. So, but we do have multiple development environments if it becomes a problem, or we break up into smaller teams to make sure that this doesn't collide too often. But then again, you write your code, your resources that you want to create or manage. So if you create a resource, it will be compared to the state, and it says, oh, it doesn't exist. We will create it. It will literally say create. And if the resource is no longer in the code, but it is in the state, it will say, I will destroy this because it's no longer supposed to be here. And if the resource is in both code and state, it will actually read from the resource API to compare the configuration of the resource to make sure that your code, whatever you wrote in your code, should align. And if it's neither in the state nor in the code, it will just be ignored. It will not be something that we manage the lifecycle of. So basically what this means is that we have something called a Terraform provider. And that is actually just a wrapper or abstraction saying that these APIs that we use for virtual machines, we can create a resource, and we need to call these APIs to create them, these APIs to modify them, these API endpoints to destroy it. That entire lifecycle is declared in the provider. And it's actually called create, destroy, and modify, or change. So the provider is kind of basic, but the cool thing is that providers can be any basically REST API. So you can actually combine multiple providers. So it's not just Google Cloud. You can combine you can combine it just for reading. GitHub as a provider, which is nice. So you can actually configure or connect GitHub repos to Google Cloud or your cloud provider as well. So you end up with kind of an end-to-end definition of something that actually works. However, all of these APIs are entirely different. It means that resources from different providers never look the same. They don't have the same needs. They don't need to configure the same parameters. It's entirely up to the API it implements. And they will behave very differently depending on who implemented the API. So Terraform is kind of easy in that sense. However, getting to know your cloud providers or your provider's API, that is actually the hard part and the fun part, to be honest, as well. So it's that simple. So then let's look at a Terraform example. Ooh, this looks a bit small here. I need to bring my glasses. So in my company, gets a GCP sandbox where they are free to do a lot of damage, basically. And it's a Google project where they can create resources. It's also a Google folder, like I said in the hierarchy, where they can create additional projects if the basic one isn't enough, if they want to try out something more distributed. And it needs permissions to do so. So you can see that first we declare something called a locals. That's a localized scoped variable. I have the suffix minus SPX, and I use 2 minuses, so I need to cut off, because what I set in as name is actually the email address of my colleagues. And I create the sandboxes based on whatever the email address is. And the length of a product ID is maximum 30 characters. So if they have very long names, which some people do, you have to cut off you have to substring it. So you actually just take the 31st characters. I still have yet to find or not 30 characters, but 30 characters minus dash SPX, so 5, so 25 first characters. But we also have sort of the organization name, which is another set of characters. So we end up maybe 20 unique characters. But so far, we have had unique IDs for all my colleagues. But locals anyway. So this is a bit of a complicated story where I have some kind of business logic that needs to adhere to Google Cloud. So this is the name of whatever the sandbox is supposed to be. So I don't want to write this over and over again. I declare it as a locals, the folder name and the project name. And I then reuse it in different places. So this is kind of a good way of doing, of not repeating yourself too much. Then our resources, we have a folder, which would literally create the folder. I have folder I am member, which just gives it a role. The roles given is actually from a variable that comes into this module. So I don't have to set it in here. It can be decided later. And I also don't want to show you which permissions I grant. So this solves two things. So this actually is one resource declaration, which uses a for loop that allows you to create multiple copies of it, basically, or multiple resources, one each for each part of the list. So you need to convert it to a set, and then you say the role will be the key, the unique value that is kind of the identifier. So it will loop over role A. So then it will be Google IAM folder .admin, and it will say the role here. So it will create one resource for each loop here. So this is kind of cool. I don't have to declare hard code this. I can just say these are actually all of them grants them admin access to this folder, and the types of admin access they need are different. Then actually use a module, and that module is created by Google Cloud, or the Google Cloud community, I would say. And it's an opinionated way of how to create a project. A project there is a resource called Google Cloud Project as well, but there are many things you can configure about those, and it's a good way an opinionated way that I like is using this module. So this will actually create a Google Cloud project. It will actually handle if you need to set a random project ID suffix, because project IDs are unique. So if you destroy it and try to create it again, you can't, because it's already taken. So it's a good practice to add a few characters of randomness at the end of the product ID. This is actually handled here, and that's a resource as well. A random ID is a resource that gets used. So then you don't have to write that. And the APIs you want to use, if you want to use compute, cloud run, functions, those are all APIs that you need to activate. And then you say, okay, I could write a loop over Google service activations, but this is also part of the module. So this more and more and more are the common stuff you need to set up when you create a project is bundled here in the project, which is nice. So I don't have to think about it. And these are versioned. So if someone thinks that there should be a change, you can actually stay on a certain version so it doesn't change. So then you can say, now I think that the active version nowadays is 18 or something. Then this allows us to actually create modules that are reusable, because we can declare them as well. And then we can version them by setting a git tag in our repo, technically. And people can actually say, okay, I stay on this version until I'm ready to move on to the next, so I understand which changes can be made. And that way our infrastructure stays kind of stable. Like I said, data is just an API being read. As you can see at the bottom here, I have a data that is called Google Workspace users. That is actually reading data from our Workspace instance to say, these are the members we have that have been registered to Workspace. And that actually gives me a data structure to work with. So if I look into data.google workspace users.users.users, I know it's silly. I can actually get the primary email of them. So every time I run this, it will use one provider for Workspace, read out all the members that I've added to our company, and use that as input for the for loop for the sandboxes, creating all of this for every single user. And that means I don't have to kind of have a list or add people. I just need to make sure that this runs every 24 hours or similar. So this enables kind of a data-driven composition of cloud resources, and they're named as something you recognize, a sandbox, a team, or maybe a web service. This basic abstraction, but when you use that word, people usually say, oh, it's abstract, I don't understand it. But it's an abstraction is something recognizable with the features that you recognize as part of that. So a sandbox would say a folder, a project, and some permissions, or a web service. All right, so reusable Terraform modules then. So you could build everything as plain resources. But is it actually what we want? Do we actually want the virtual machine, or do we actually want the cloud run service? Well, no, we want something, a web service people can access over the web, for instance. And it turns out, if you want to build a cloud function using Terraform, you actually need a storage bucket to put some code in, IAM permissions to make it publicly invocable. You should use a service account to run it as. So in case something goes wrong and someone has access to, can make your function call Google's APIs, it shouldn't have permissions to change something within Google Cloud. So it should have a service account. And that service account should also have permissions. So it means that even if you just want to create a function and run it, it will actually have to create all of these. If you go into the Google Cloud Console or the Google CLI and click, it will actually do all of this. You will actually have some input boxes. And the problem is that if you want to tell someone else how you did it, again, we're talking about what was the process to do something. It's actually kind of hard to do. If you write down and say, I clicked here, wrote this, clicked here, wrote this, clicked here, wrote this, and then Google does a rollout of a new GUI change and it doesn't suit anymore. This is why we have infrastructure as code. It's reusable and repeatable. And this is actually kind of a lot of work. So you won't get it right the first time. So you want to be able to kind of use this as a versioned item or entity of something that you reuse. Same with Cloud Run. You can set up a Cloud Run function and you can kind of deploy to it. But if you want to do it in Terraform, so Google doesn't set up everything for you automatically and you have control, you have to have the Cloud Run instance. It has to have IAM permissions, saying that all the users are actually invokers of this function, so it's publicly accessible. You need service accounts again for the Cloud Run to run as. But building is actually not part of, that's the difference between, say, a function here. Building is actually a part of the cloud platform here. It's not something that gets done in Terraform. Building here is actually done in Terraform. So then you need another service account that runs the cloud build function or cloud build service. And you need more permissions. And you also need to store the image in a registry somewhere, and that's an artifact registry. So you end up with a bunch of resources and you also want to connect it to your GitHub repo. So this is actually where it's useful. You write your code, triggers a build, deploys a Cloud Run, and a customer can access your service. This is not something you get right the first time. The first time you build it, you make it work. But then you actually have to, and if you do it as loose resources, you end up with these two actually being mashed together, say, just in a bunch of files. Someone says, oh, I can reuse the service account for this into that because it's kind of the same. And, oh, these are the same permissions. And it kind of gobbles together in something you don't know actually how it works. So this is why we do a lot of modules, because you will get it wrong. I got it wrong many times. Google changes something that you need to figure out how to do better, or there is a better kind of best practice to do things. So this is why we actually have versioning of these modules. So we use them a lot, and then you update. Usually the case when I ask a client, oh, is your web service solution secure, or are your web services secure? Yes, they are. The problem is that they didn't modularize. So you have kind of the entire generation of web services going forward, from the kind of basic I exposed a cloud function on the internet without a load balancer to the bulletproof thing at the end of the timeline, if you know what I mean. They never answer questions about the first thing, but that thing is still live. If you would create a module in the beginning and say, okay, this is how I run my web services, and then you upgrade that service over, or the module over and over again, and deploy your services all in one, it means all of your services are upgraded and fixed. And this is actually something I talk to a lot of very seasoned DevOps people and also developers. You start out with resources, yes. Once you're happy how it works, maybe consider creating a module for it, because it's an entity of something. And you don't need to share it even. You can just create a module locally to say, this is actually part of the web service, this is part of some other service, this is part of something else that's doing this. But breaking it up into modules is a really good recommendation. Wrap up. We're almost at time, I think. We have, as I mentioned, Cloud Skills Boost. I can really recommend this. I think I might have been lying a bit when I told you what we would learn in this course. Like I said, developer learning path is great. Cloud fundamentals would be basically what you would expect of a cloud introduction. Say, this is how Google's global network works. This is where you find your data centers, how data centers are composed to regions, sort of that sort of thing. And then one of the things that it's part of that learning path, by the way. But developing applications with Cloud Run on Google Cloud Fundamentals is also a really good start on how to get started with Cloud Run, for instance, because that's one, if you just want something running on Google Cloud, that's a really good start. The Cloud Developer Learning Path does include Kubernetes. So you will end up creating Kubernetes clusters and working with them, setting up ingresses or API gateways, as they're called nowadays. Like I said, these cost credits, I think you can get some free as a student, not sure. I had to sign up for this Innovators, that was the name, the Innovators program, and I get 35 credits per month. I'm also a Google Cloud Service partner, so I get all of this for free all the time. So that's why I'm not entirely sure how this works, because I always have access to all of these labs. And there are great resources for running Terraform online as well. So if you want to have, if you want to try this out, there is one specifically said how to set up remote state. That can be really good to do, to see how do I actually set up Terraform with Google Cloud. Since we actually have 13 minutes left, I could have included this in these slides, but you never know how fast something will take. And that is about it. And don't forget to set your billing budgets, kids. Really important. It can be scary. I tried AWS a couple of months back, and I ended up with a bit of a bigger cost than I wanted to. So that can always be the case. Right. Done.
Ah, beautiful. Thank you so much. Ska vi se nu. Yeah, one thing, yeah, with the billing budgets and stuff, it is really important that you're careful with this. It is easy to get confused by Google billing, especially if you create virtual machines. So I think that's you mentioned in the beginning, using cloud functions and things that can scale to nothing is very important. You can do it for your assignment too. For example, it's perfect to start there. And it will be a little bit slower to start up, but your 300 credits, $300, I think you can get with whether you're a student or not, if it's a new account. and it gets you pretty far on those resources that do scale down.
Yeah.
But if you create a virtual machine with storage, that's where this will all fry, and it can be like
Yeah.
500 per month.
It's yeah, but it's not. It's actually quite cheap. But don't create SSD disks. You don't need it. Create plain magnetic disks. They will default to kind of large sizes. You don't need 100 gigabytes. Just pick 10. And I mentioned this in my slides, but I forgot to mention it out loud. It's that when you create your virtual machines, you can create something called a preemptible machine or a spot. They're using those interchangeably now. It means that the machine will only live for 24 hours, but the price of the machine is 20% or so, I think it is, roughly, of the actual machine. So when you create your Kubernetes cluster, use preemptible machines. And it's actually great because your services are supposed to handle a node crash or node outage. So do so. It's just going to show you where your gaps are in your services. So I used to do this, and I was able to run a Kubernetes cluster for months. Now Kubernetes is a bit bigger, so you need bigger nodes, and I'm not quite sure how large nodes you need for Kubernetes. But do consider choosing smaller machine sizes and preemptible disks. I would say that's the kind of impact on it, and you get an estimate of how much everything costs when you create it. So there won't be a surprise, but auto scaling, keep down auto scaling allowances so you don't end up with someone DDoSing your servers and you're pulling up, say, 50 instances of a Cloud Run or 50 instances of a Kubernetes engine.
Mm.
Yeah, you're right, entirely.
Yeah, that's. I was. It was nice with the example for the sandbox. Is that publicly available? Could you share that code for the Terraform? If like, what is like you recommend as maybe something else that you recommend as a quick start on GCP with Terraform and setting up some resources?
Yeah, I have some internal labs I could share with the group on my GitHub if you want. It's actually more of a. It's actually hosting a web page, I think, as a storage bucket and using a cloud function as a backend. So that could be a good start.
Yeah, exactly. I think it's my tip is like don't be afraid of this large platforms. Yeah, maybe it's like we've been comfortably working in OpenStack and things have been managed. You usually get like at the university like just login credentials to your like a VPS, and I think many students use like Render or similar like managed hosting. So this might be the first time you go like out in the wild, and it can sound scary, like especially when each platform has their own like set of förkortningar, like with a lot of
Abbreviation bingo. Sort of.
yeah, exactly. But it is actually not that complicated, and specifically for Kubernetes, I think it is simplifies things a lot. If you get to try the managed Kubernetes, it works out of the box. So that's really worth a try. And I think those links, we will share the slides. So the links to step-by-step tutorials on Google are really cool, really good, and I hope you get the time to try them out with Terraform, and then you could use them for the rest of the course.
When you run the labs, make sure to run them in an incognito window, not on your own profile, so you don't accidentally connect to your own instance and spin up something large. So always use incognito windows there. That's what they recommend, but just don't forget it because it would be silly if you have a free sandbox where you can go bananas for 4 hours and Google takes the entire cost, and then you accidentally spin it up in your own instance and you take the cost for it. So
yeah, exactly. So it's they do ask for your card when you create everything.
Yes.
So just be careful so we don't end up also. Yeah, Oksana said it's okay to use Google Cloud. No. So
but it does rarely happen, but just there are a few. I've seen it happen mainly in companies. So take it easy a bit. And set billing budgets so you know. And then you can share your worst stories after the course if something happens. But usually it never happens in this kind of level. So it's usually fine.
That's nice. We don't have many questions from the audience, so I think we'll wrap up soon. I just want to ask a little bit about your experience in general for a web developer. How important would you say it is to get into this DevOps, Terraform, infrastructure as code, or is it often abstracted away to different specialities? How is it?
Ooh, there are different approaches to this, and I would say the larger companies, like the big companies that you've heard of, basically the ones that you visit every day or shop by every day, they tend to have sort of an abstraction where you just push code and it gets deployed somewhere. But to troubleshoot, you actually have to get into this stuff. So you definitely should know it. I would say a Kubernetes abstraction is usually what you get. It's quite common that here's where you put your manifests. This is where you push your image, and you need to make sure that that image matches for the next version, and you get. So you are often exposed to Kubernetes, I would say. I usually call them Kubernetes shops and sometimes Kubernetes cults, because they can become very tool-oriented in Kubernetes companies. And I think that can be a bit of a danger, to be quite honest. But when you go to Google Cloud, some companies just give you a sandbox. This is your team's sandbox. Here's your project to store your Terraform state, and this is your responsibility. And we'll just tell you what the bill was, or tell you when it's starting to go high. So you usually get a lot of access directly to either Kubernetes or to Google Cloud. Some companies do create it's more locked down than you have. That can be a real challenge. And some companies have created more of like an abstracted development environment, but you need to be actually bigger than most Swedish companies for that to make sense. You have to be more like Netflix. Because I've seen it done on some of the biggest companies in Sweden, and they usually fail. And they fall back to saying, no, we can't really manage it in an abstracted way, because teams always need something else, right? Remember the surly kid in the beginning? That's us. We want something else that's actually provided by the abstraction. So that's usually an issue where to find the point. So yes, you do need to know this. Containers is something you definitely need to know. You won't just use it for hosting, but also for developing. You use dev containers everywhere to make sure that everyone gets the same environment. It works to develop on my machine. It works to develop on everyone's machine. So the development part actually can be as important as the hosting part, because if something breaks in your cloud environment, or your development environment doesn't work, it could stop 10, 50 developers from working, and that's a lot of money that goes out the window. So do learn containers a lot, I would say.
And Terraform a little then too.
Yeah, Terraform is actually when you work on the platform side of things. Even if you work an entirely Kubernetes-oriented shop, there are things that Kubernetes can't manage. Google has tried quite well with something called, I think it's called Config Connect, or Config Manager, or Config Connect, I think it's called, where you can actually create other cloud resources. But the abstraction doesn't really hold, because you can't pass outputs from one resource as an input to the next. That's not really how Kubernetes works. You need to create the manifests directly and figure those out. So even if you have Kubernetes, you also say, okay, I also need to create something that's outside of just Kubernetes. So you end up working with Terraform as well. But that has not come as far, I would say. More like platform teams work with Terraform, and some work with for developers. But I think it's leaking more and more towards developers. So
yeah,
yeah.
I think also that many people are sort of worried about AI taking over large parts of so classic web development. There are more tools like Lovable and the other sort of code generation and the platform generation things coming out. So I think that this part that we learn in this course, and how to actually scale applications, how to put it in production, and being able to go a level down, that's what this would distinguish you on the job market from just a classical web developer.
Yeah, definitely. I mean, even if you have Gen AI tools, which we do use a lot, we still have to review the code. You have to define the process for these tools. How do I actually, what is successful? What does success mean? And how do I actually validate what they have created is something useful for us? And is it also maintainable? So the difference in how you work is that you sort of become the team lead for a bunch of junior developers. That's basically what the playing field is right now. So you have to think more than just technology. That's why this presentation was a bit different. You have to kind of be the one that tells all of these agents how to actually make the technology fit what you're trying to achieve. So I think you will stay junior, not shorter than usual in that sense. You have to kind of step up and think about business, about organization, and be basically a team lead. So that's going to be a difference. That's going to be a different case. But you also need to know technology to be able to evaluate the expected results, basically.
One more question we have here from Rome.
Oh, yeah.
More like a tip.
Yeah, whack-a-mole. Yes. It's nice to have an author of the solution there. Yeah. I think it's. I will definitely scrunch it up from my GitHub repo.
That was the project that you talked about, right? Can you?
Yeah, sure. We can take a few minutes. So we were introducing Kubernetes at a local company, and I got a question: what would be fun for DevOps teams to learn? And I just set up a solution where you could have Kubernetes clusters running across multiple Raspberry Pis. And you can actually have, I had color-coded LEDs. So whatever pods came up, you could put a label on them to say that you should be a green pod or a blue pod or a yellow one, and the LEDs would turn on, basically. And so that's where it started. And then the other two in this company had the idea that, oh, we should do like a wars. So we started with a cluster, you join the first ones, put on some loads, and the lights would shine up saying, this is your backend service, this is your frontend service. And then you could scale it up by saying, I want 20 replicas, and then would actually fail to scale them up because we didn't have enough resources. Then you would add another Raspberry Pi blade to the mix and scale it up. And then I think it was Jonas who had a really cool idea where he said, why don't we do like a game, a war game? So everyone had their own cluster with lights blinking where it would be red to turn off. It would blink green when it turned on. And then we would have a playing board or a game where you could log into a web page. Every time a service turned on, a mole would pop up on a green field, and you would see whose team it was. And you could choose to either have the DevOps guys try to beat the other guys' moles. And every time you hit the mole, it would turn the service off. It would kill it, basically. So we would end up having, like, you could be offensive and kill the other people's services, or you could spend time on trying to optimize how fast can we start up new replicas of the old service and make sure that we would win, basically. And if you manage to kill everyone else, another team's kind of all of their moles, you would end up with a timer or a count that would kind of say that you're getting score here because the other team's services are down. So that was an excellent workshop. I wasn't able to be present for it, but I still have the code somewhere.
Yeah, we'll see if we can spin it up later in the fall when we get to scaling on Kubernetes. And I think it's also, if you like this kind of type of things, is a good group project. It can be made to that with some nice front end, and the Kubernetes wars could be really fun to see.
Yeah, I'll have to reach out to Jonas there to see how the hardware was. I've lost mine, unfortunately, but I think you can build more. So
yeah, we have also connection here to the IT lab and studio, at least here on site. in Kalmar there are this possibility to loan a Turing Pi or a Raspberry Pis. We have a bunch of Raspberry Pi Zero, so that's definitely possible to spin up a real hardware cluster. So yeah, could be really fun. It was a pleasure having you. I think we should wrap up, and we'll see if we see you again later in the fall for more practical tips on Kubernetes. And thank you again. It was really nice to have you.
Yeah, this was fun.
All right.
Thanks a lot for having me.
Yeah, bye bye.